I was looking through the math subreddit and I found this really messed up differential equation by user acrobatic alone. It's a pretty messed up differential equation. The second order term, there's like cosine sine, there's e raised to the sine. It's just a cluster mess. Yeah, and we're gonna solve it because I hate my life. Special thanks to Seriously Psyched and Cool P15. They basically did all the work, and I'm just basically regurgitating what they told you. Alright, hold on, let me turn on a light. Say hi to Turtle Man. This equation is pretty messed up because you see there's a d right there, there's a d, there's du squared there, there's du, there's a u, there's cosine t. Like, you really can't rearrange any terms without messing up the right side. So, first thing to notice is that these two terms, they follow this is the derivative of this, and this is the derivative of this. So by product rule, which states that f of g prime is equal to f prime g plus g prime f, you can see that one of them, if you just set f prime to be equal to sine, f prime to be equal to sine, f is negative cosine, g is u, g prime is du dx. This follows the form of this. So we can rewrite this as u double prime u squared is equal to d over time minus cos t u prime, and now just say right hand side. I'll show this, I guess, if you don't believe me. You can bring the negative sign inside. Negative cos t u prime is equal to negative cos t u prime plus the derivative of negative cosine is just sine and u, which is what we have right here. So this is true, okay? And now I'm gonna rewrite this the second derivative of u as u double prime. It's just a way to it's a way to make this easier for me. Minus u minus cos t u prime is equal to the right hand side. Okay, so this also follows another limit law, mainly that f prime minus g prime is equal to f minus g prime. So we'll just rewrite this as u prime minus cos t u prime to the right hand side. Now remember, when we say prime, we're differentiating with respect to t, right? So you can rewrite this as d, and this function is equal to u prime minus cos t u dt is equal to cos t e to the sine t. Bringing the dt over this side, you have dt, and you have d net u prime minus cosine times u. You just integrate both sides, and you get u prime minus cos tu is equal to, oh, right here, this is a very interesting trick. Let's just see cosine of t e to the sine t. Right off the bat, we can see that cosine is the derivative of sine. So let's hypothetically, if we say some function t is equal to e to the sine t, the derivative of this would be equal to cosine e to the sine t. Sorry, my handwriting got really bad there. Let me try to make that better. It would be cosine e to the sine t. Now, that's what we have right here. So, fundamental theorem of calculus says that the derivative and the integral are basically inverse operators of each other. So, when we do this, when we do the integral of this derivative, we get the original function plus some original term. So this would just become e to the sine t plus e to the sine t plus some constant. Okay, so now this is a first order homogeneous equation. You have u prime minus some function of t times u is equal to some function of t again. This e to the sine t, and this is constant. This is pretty easy. We have to just add an integrating factor. So the way we do this is that we see that u prime minus cosine of tu is almost like this form right here, where we have f prime, oh, not this form. It's almost like this form, fg prime. If we can multiply some integrating factor, we'll call it like, I don't know, like, let's say we multiply by some integrating vector of rho of u, such that if, when I multiply it, this becomes rho of u prime minus, let's say another function, let's just call it like alpha of rho, alpha of u. If alpha of rho is equal to, the derivative of this is equal to rho of u, then we can just combine them under the product rule. We add a plus sign right there. How does this work? Yeah. So I'm not gonna go to the derivation. But the integrating factor, the row of u, the integrating vector that we multiply by is equal to e raised to the integral of p of u du. All right. P of t dt. Now let me explain what this means. Okay, what is p? This equation can be written in the form u prime is equal to p of some function of t. Oh shit, my bad. U prime is equal to, oh, I did it again. P prime plus p of t u is equal to some q of t. Now, this is where the p of t comes from, and we can extract this from it. How we get to this step, I really don't want to go through, but it involves some like algebra. It's not too hard, but we're just going to invoke the trust me, bro, because I don't want to explain it right now. All right. So our equation becomes u prime plus, u prime minus cos tu is equal to e sine t plus c. Now we're going to multiply this entire thing by the integrating factor, which is just e raised to the integral of this function right here. The integral of negative cosine t dt is just equal to e raised to the negative sine t plus, do we do plus some constant c. This becomes e c1 times e negative sine t, because this just carries over from the exponentiating laws. By the way, you don't really need this term, because we multiply this factor on both sides by some factor of rho of t. Whatever constant comes here is going to be on this side, and it's also going to be on this side. So we can just straight up just divide by that constant. So yeah, I'll just do it anyways to show you guys. So we'll have some constant. We get e of negative sine t u prime minus e of negative sine t cosine of t u is equal to e to negative sine times e to negative sine. Well, this just cancels and becomes 1 plus c, remember, because c, so e to the negative sine t c. And there's an extra, this is what I was talking about, there's some constant that gets multiplied on the other entire side. So I guess we can say like this thing is entirely multiplied by like C1e, and this thing is multiplied by C1e. But as you see, they're on both sides, and it's non-zero because e multiplied by some constant. Oh, actually, you set C1 to equal to 0, then this doesn't really, then this equation just becomes 0 equals 0, which has no information, so it can't be wrong. So we're just going to ignore it. Okay, yeah, clearly you can see that this follows a product rule. You're gonna have to trust me on this one, but this follows a product rule. I'll just show it, why not? E to the negative sine t and u. The derivative of this is equal to the derivative of this, which is equal to, well, let's just start with this side. It's equal to the derivative of this is equal to negative cosine t, e negative sine t, u plus, then the derivative of that is just e to negative sine t, u prime. And clearly that this corresponds to this term, this corresponds to this term, so this becomes that. This follows from the product rule. Okay, so now that we have another form of this, we have e to the negative sine t u dt is equal to this abomination, c e to the negative sine t. Okay, now we just bring the dt over, and we integrate again. We get e to the negative sine tu is equal to c, integrating this is kind of messy. How do I integrate this? Wait, I forgot how to integrate this. I don't think this actually, wait, this is the problem. You can't, this function can't really be integrated because it's e raised to a trigonometric function, and I don't think it can be integrated. So it just becomes e. I think we just leave it in this form, sine t dt plus some constant c. Now let's solve. Let's just multiply both sides by e to the sine t to the sine t. E to the sine t. We get u, this is our function, this is our original function. U is equal to the integral of c e to the negative sine t dt plus e to the sine t times c, another c. Let's just call this constant c1, and let's call this constant c2. So that is our answer to the solution. So if this function right here is the answer, satisfies this equation, which is pretty crazy, you know. We had to go through we went through one reduction to turn it into a first order homogeneous solution right here, and we went through another reduction to turn it into just a regular differential, we turned the first order homogeneous equation into just a regular equation, and we got some insane integral right here. And this really can't be solved by elementary functions, because you really can't do integral of e to the negative sine t unless there's some exotic like method, which I just don't know. Anyways, that's basically what Wolfram alpha says. X of t. I use x in this because Wolfram thinks that u is some atomic mass. We have e of the sine t. It seems Wolfram alpha found the cosine term in it. Okay, I'm going to have to check my math, but I think what we did was okay. I guess that's what the function looks like. Or I'm just wrong. Feel free to tell me.